As we start chapter 15, we're actually going to be building on chapter 14's material. We're going to be using a lot of the same terminology and formulas and changing up some of the things that we've learned. So let's take a look at one of the old formulas. So last unit, we learned the word disjoint or mutually exclusive. So when A and B are disjoint or mutually exclusive, that meant that they had no outcomes in common. And so we learned that the probability of A or B was the following formula. The probability of A or, remember that U-shaped symbol, that was or, B, equals the probability of A, and or always meant add the probability of B. So that was what we learned in chapter 14. And we were able to use that formula because all of our situations in chapter 14 were mutually exclusive. Now, we're not going to have that situation. Now, A and B are no longer going to be disjoint. In other words, there are going to be things in common between the groups. So we need to keep this formula, but add something to it. So we're going to keep the probability of A or B. It's still adding. Probability or always means add, but we need to take out something because here's the thing. What they've had in common, we counted those when we did the probability of A, and we counted those when we did the probability of B. So we're simply going to subtract off the probability of A and B. This part right here is the overlap. So whatever they had in common, that's the part that we're subtracting. So let's take a look at some examples. A survey of college students found that 56% live in a college residence hall, 62% participate in the college meal plan, and 42% do both. So right away, you just heard people do both. We're going to answer the question, what's the probability that a randomly selected student either lives in a residence hall or has a meal plan? Well, one thing that is a very helpful visual tool is a Venn diagram. And I'm pretty sure you guys have used these before in an English class. These allow you to compare two things. So I'm going to show you how to use this Venn diagram, and then we're going to use it for our examples today. So what are the two things we're talking about? Well, we're talking about people who live in a residence hall and people who do a meal plan. So I'm going to label this RH for residence hall and MP for meal plan. The area that you always start with when you're filling in your Venn diagram is the overlap area. That would be this area here. So how many people did both? Well, that was 42%. Well, as you know, probability, we always use decimals instead. So I'm going to take that 42%, divide it by 100, and I get 0.42. That's the easy part to fill in. Now we got to look at the other part. Let's start with residence hall only. That's the people that are on this part of the circle. Well, we know that 56% live in a residence hall. Here's the thing. That 56% is the entire residence hall circle. So in order to figure out the people who only live in the residence hall, we need to take that 0.56, subtract the 0.42 that belongs in the middle, and that leaves us with 0.14. So 14% live only in a residence hall. Let's do the same thing with the meal plan. Well, the meal plan, we had 62% do a meal plan, but we got to subtract the 42 that's in the middle, and that leaves us with 20%. Well, there's one other area in a Venn diagram. If you notice, I have a rectangle around this shape. There are people that go to college that don't live in a residence hall and they don't do the meal plan. That's the outside part. So one thing we know, the perfect percentage is 100. So we're going to take the 14 and the 42 and the 20 and add them up. Well, 14 plus 42 is 56, and 56 plus 20 is 76. So then, to figure out what's left over, we're going to take 1 minus 0.76, and that leaves us with 0.24. Those are the people that go to school but don't do either one of those things. So now that we've completed our Venn diagram, now we're going to answer the question that it asked. It asked, what's the probability that a randomly selected student either lives in a residence hall or has a meal plan? Well, the one thing in math, when we say the word or, we are also including the situation of both. So all we have to do is identify the numbers that we need and add them up. So that is 0.14 and 0.42 and 0.20, because those are our circles. This was residence hall, and this was meal plan. And that gives us 0.76. Now, if we wanted to use the formula that we learned on the previous slide, we would say, well, the probability of a residence hall from up in the original word problem is 0.56, plus the probability of a meal plan was 0.62, but we have to subtract off the overlap, and that was 42%. And so if you add those two numbers and subtract 0.42, we get the exact same answer we just found. So you have two options in solving these problems. You can use the Venn diagram, which a lot of students think the visual is very helpful, or you can use the formula. But for the rest of the examples, I'm going to focus on the Venn diagram. So let's keep going. Next example. In this textbook, 48% of the pages have a data display, some sort of graph, 27% have an equation, and 7% have both. What is the probability that a randomly selected page has, and we're going to answer 3 questions. Well, what are the 2 things we're discussing again? That was a data display or an equation. And where do we start? We start in the center. What percent had both? That was 7, so 0.07. To find out the number of pages that have only data, we're going to take the 48%, we're going to subtract the 7%, and that leaves us with 41%. The equation, we're going to take the 27%, we're going to subtract 7, that leaves us with 20. And don't forget, we have that little leftover spot. Well, we have 41 plus the 7 in the middle plus the 20. That leaves us with 68. And 1 minus 0.68 is 0.32. There's your people or your pages that don't have data displays or equations. So now, let's answer our questions. The first question was, what's the probability that it has a data display or an equation? So data display, only 0.41, both 0.07, equation only 20, which we've already added up and we knew that that was 0.68. what's the probability that that page has neither a data display nor an equation? So that was the leftovers, which we already found, was 0.32. And finally, CS, what's the probability that has a data display but no equation? So the only one on here that satisfies data display but no equation is this part, this part right here. That's our data display, but it leaves off the equation. So 0.41. All right, so let's keep going. Why don't you guys pause the video here for a minute and see if you can try this one on your own. When you're done, simply click play again, and I will go through it with you. Alrighty, a police report that 78% of drivers stopped on a suspicion of drunk driving are given a breath test, 36% a blood test, and 22% both. So let's do our lovely Venn diagram. So we had a breath test, and we had a blood test. 22% was both. Breath was 78. Take away 22. 22, there we go, which is 56. And blood was 36. Take away 22, which is 14. So hopefully you had those numbers right. When you add up those three, 56 and 22 and 14, you get 92. And the leftover, if you subtract from 100, is 8%. So hopefully you had the Venn diagram right. Let's see if you answered the questions correctly. So a breath or a blood test was when you added up the three pieces. That should have been the 0.56, the 0.22, and the 0.14, which was the 0.92. So hopefully you had that right. A breath test or a blood test, but not both. So that was just the 56 and the 14, which was 70. And finally, neither tests. That was the leftovers. That was our 8%. So how'd you do on that one? Not too bad? All right, so let's look at the next example. Why don't we do this again? Why don't you pause the video and try this one on your own, and then we'll start it up and see how you did. All right, so suppose the probability that a U.S. resident has traveled to Canada is 0.18, to Mexico is 0.09, and to both countries is 0.04. Let's do our Venn diagram. Now, notice the numbers, I didn't say 18% and I didn't say 9%. I said 0.18 and 0.09. That means that they are already in decimal form, so no need to change that. So our two countries were Canada and Mexico. We already know that both was 0.04. No need to change that. Canada was 18. Take away 0.04. That leaves you with 14. Mexico was 0.09. Take away 0.04, which leaves you with 0.05. So there's still a whole lot left over. So let's figure out the leftovers. 14 plus 4 plus 5 gives you 23. And 100% take away 23 leaves you with 77. So let's answer the questions. So the first question asked you what percent traveled to Canada, but not Mexico. So we want Canada only. So that was 0.14. traveled to Canada, to either Canada or Mexico. So that is Canada, both, or Mexico, which is the point 23 that we found earlier. And then what's the probability that they've traveled to, that they have not traveled to either country? That's your leftovers, which is 0.77. So hopefully you're looking at these and you're thinking, wow, these are actually pretty easy. So we have one more example to look at. This one's organized differently. This involves a table, so we're going to go through this one together. A survey of students in a large introductory stats class were asked about their birth order. When you see one or only, that means that they were the oldest child or an only child, and which college of the university they were enrolled in. The results are in the table. So we have two options for birth order: oldest or only, or the second or more. And then we have four options for college. We have arts and sciences, agriculture, human ecology, and then simply other. Now, we've used tables like this before. You guys know how the different totals work. So let's take a look at our first question. We want to know, what is the probability that, we're selecting a student at random. So what is the probability that the person is a human ecology student? So human ecology is right here. We're going to come all the way over to the total. And so that's 43, but probabilities are fractions. So that's 43 students out of 223 students. And if you tried to reduce that on the calculator, it can't be reduced. So we're done. So now, what's the probability that the person we chose is a firstborn? Well, firstborn also includes only. That's this category right here. So we're going to go down, and there's our total for firstborn. 113 out of how many again? 223. So now we're getting a little more specific. Now, what's the probability that they were firstborn and human ecology? So firstborn is again right here. I'm going to go down to human ecology, and that's the number right there that is firstborn and human ecology. So 15 out of 223 kiddos. And again, that's reduced. So now we look at one last question. Firstborn or human ecology? Well, or means add. So firstborn, we've already learned from part B, is 113 out of 223. Or means add. Human ecology, we learned from part A, is 43 out of 223. However, we counted some kiddos twice. So we need to subtract off the students that we counted 2 times. Well, those are the kiddos that are both firstborn and human ecology. That was the 15 that we used in part C. Those 15 kids were counted 2 times. So we're simply subtracting off one of those so that we don't count them twice. Since all of these have a common denominator, the denominator is not going to change. 113 plus 43, take away 15, leaves you with 141. And that's your final answer. And that's the end of our first chapter 15 lesson.